Hello, I've just finished repairing this Roland 600A for the second time. The first time it came into the shop, it had a distortion on the left channel. Now when I hooked it up to the oscilloscope, it was showing me a clipping positive waveform for just the left channel. Now I managed to track that down to, let me see, oh no, that's the preamp board, but if I have a look on this schematic here, this transistor here, 1382, C1382, transistor 605 was at fault. I replaced that, happy days. Both left and right channels had nice clean outputs. So I called it good. I did some power tests and things and everything looked good. What I didn't pick up on was the fact that when the customer took it away, they hooked it up to some speakers and they said, one channel's weaker than the other, which was actually what the original complaint was. But the original complaint was the left channel was weaker than the right. Now, when I hooked it back up to the scope the second time around, the left channel's working beautifully and you get about 16 volts RMS on the scope, but the left channel was significantly less. What I've just tracked the fault down to be was on this preamp board, there's a wee cap in there. You can see that new multi-comp cap in there with the black dot on the top. That's the new one that I've put in. Old one is right here. You can see the bottom bulging out. And it was actually testing all right on the ESR meter, but I thought I'd just swap it out anyway just to be safe. And sure enough, I'll show you what the waveform looks like now. So left and right channels clipping at the same point at about, well, just under 16 volts, I'm going to say, probably about 15 volts, which is awesome. So two faults with this one. There was the transistor 605, which is a 2SC1382, and then there was that cap, which I'm going to have a look to see where that actually is in the schematic, just to make sure it does correlate with the right channel. If it doesn't, if for example it's actually part of the left channel's schematic, then I'm going to assume by touching up one of the dry solder joints on the bottom has actually fixed it. But definitely thinking it's the cap at this stage, because that bottom just looks quite puffed out, certainly more so than all of the other ones. So yep, job's a good one. So I've just identified where that cap actually is on the board. As you can see, this is the volume pot, this is the balance, and it's between the two right here. Looking at the board view, use the mouse to show you what I'm talking about. Here's the volume control pot here, here's the balance control pot here. The cap, electrolytic cap anyway, that sits between the two is this one, C525. It's 100 mic. What voltage was that one? Original one was 6.3 volts. I think I've put in a 16 volt or something like that. It's a 10 volt, which I've put in. So that's C525. So if we go have a look on the schematic for C525, let's see, where are we? This one here, I believe. And we are over here. See, let me zoom in a bit. Sorry, this is quite tedious. Where's our volume control here? C, oops, sorry, you can't see. C5, 25, 6.3 volts, 100 mic. This one right here. And this bottom portion of the schematic is for the right channel. You can confirm that by following this node. Following this node here, node 11, up to this one here, and this is the right preamp out, which is right beside the right preamp, right main in. So that confirms that that cap C525, which is connected to the emitter resistor of transistor 506, definitely could have been the culprit. So if it was leaky or just not behaving right, then it's gonna change how this transistor performs, and therefore weak output. Although the signal still looked like a smooth sine wave, it was weaker than the other channel. I wonder if I should do the equivalent C525 for the other channel while I'm in here, which would be C507, which I think I'll do right now, and then I'll test it again on the scope. So just found C507, it's right up here in the top corner. Oops, let me zoom in. This one here, C507, 100 mic, negative is up to this top plane, which would put that as this component here. Let me see if I can grab any ratings off that just to make sure. 100 mic 6.3. Yeah, so I'll swap that out for the equivalent, and away we go. .3, 100 mic. Let's grab another one the same as what I put in there, 6.3 at 10. No, 100 mic at 10. Mic at 10. Here's 100 mic at 10. A lot smaller. I wish I didn't just burn myself. It smells like chicken. It's making me hungry. Alright. Let's get this one soldered in. There we go, that one's in. Let's give that a whirl. Amp is off at the moment. Plug it in. Turn the volume down, it's down. We've got our input at 370 millivolts per kilohertz. Turn that on right here. There's our aux2 light. So 370 millivolts at a kilohertz coming in. Volume control. Here's our dummy loads here, which get really hot, by the way. these are supposed to be 100-watt dummy loads, but they're definitely not. They basically burn through this mat when they're running at about 30 watts. Right, so let's have a look at the scope. Both channels set to 10 volts per division. Cranking it up. Looking good. And yep, she's distorting. They're both distorting at the same spot, which is really good to see. 15 volts output. So what is that? 15 times 15, 15 squared divided by 8 watts, 8 ohms, 28 watts per channel before distortion. Cool. Happy days.